Hello people, welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone is doing good. I am Vignesh and in this video we are going to do a hands-on on how to build a streaming ETL pipeline in Google Cloud Platform. For this we will be using services like Cloud PubSub for streaming and Cloud Dataflow, Apache Beam will be acting as a compute, Cloud Storage for temporary and staging logs, and finally BigQuery will be acting as a sync here. So in my previous video, I have explained you how to build that batch processing ETL pipeline along with how to orchestrate it using Cloud Composer. So this video is also very similar to that, but there is two changes. It is going to be a streaming and we are not going to orchestrate this pipeline. So I hope the objective is clear, and without any further delay, let's get started into this. So for this video, I'll be logging into my console, Google Cloud Platform, and in this video, I'll be using Workbench. So in my previous video, I have explained you or I have done the lab using Cloud Shell, Cloud Editor, or from Compute Engine. The same way, we are going to create a Workbench managed notebook, and we will be doing everything from the Jupyter's lab actual terminal itself. So this is what we are going to do, and this is also quite popular way. In real time we will be using for everything we will be using Compute Engine or terminal only. So this is also going to be very similar to that. First, you have to make sure the data flow is enabled inside your project. So this is my cloud console, and this is what we are going to do. And I'm going into my Workbench. Under user managed notebook, I'm going to create a Jupyter notebook, or I'm going to create a Jupyter notebook with runtime environment as Apache Beam. So just click on this new notebook, Apache Beam, and without GPU. So just give your notebook a name. I'll just open this advanced options. So I'll show you how to create what are the parameters I'm going to configure inside this environment. So I'll just rename this into demo ETL streaming pipeline. So the region, let it be US Central one, and zone, let it be US Central one. So rest everything, I'm going to keep it as the same itself. Environment will be Apache Beam. If you want to run a startup script, the same way how we did it in Compute Engine, right? The same way. If you want to add any metadata, you will be able to add it. And next thing is machine type. So here you can see all the machine types available in this particular managed notebook, user managed notebook. So you can go to N1 standard, and you will be able to go with N1 standard V, virtual 4 virtual CPUs 15 GB RAM, or 8 virtual CPUs 30 GB RAM. So I'll be going with this. GPU type is none, and rest everything we'll go with this what default values, and this is what it is going to cost us. Don't worry, we'll be deleting this instance once the lab is completed. So rest everything you can just keep it as per the same itself. So networking we are going to use default, IAM is we are going to use default, everything we are going to use default. So it will take some time to create this environment, like around 4 to 5 minutes we have to wait in order to create this, in order to this environment will be provisioned at this time. So if you just refresh, you will be able to see one notebook which is currently in the provisioning state. So we will get back to this later. Now I'll explain you what we are going to do. So first I'll open my Visual Studio Code. I'm going into the code, which is the actual, this is what we'll be building it. So the code which we are going to use in this lab, it is taken from Google Cloud Platform's actual repo. So that is very popular repo. We'll be using whatever the use cases which we are discussing or which we are going through, everything will be taken from, like it is referred obviously from official documentation, or it is from the official Google Cloud repo itself. So they are just importing the packages here. Import argpass, like we are going to take we are going to take argument from the user itself. So we are using this argpass, time, logging, JSON, typing, datetime, and we are importing the Apache Beam. So import Apache Beam, Google Cloud options, pipeline options, the standard things which we are going to, we'll be importing this. And from Apache Beam, we are importing this Dataflow runner. So we are going to use this Dataflow runner since we are executing, or the actual runtime environment is Dataflow. We are using Google Cloud Platform. So that is the reason we will be using this Dataflow runner. If you wanted to run it from local, then you will be able to use this direct runner, or if you wanted to run it from other runtime environment like Flink, those things, you will be able to import the respective runtime environment. There are totally around 6 to 7 runtime environments which Apache Beams totally supports. So here, this is what we are going to do. This example is nothing but um, we are going to read we are going to read the page views, which is going to happen at the real time itself. So what is, for example, you will be using how many users are using Chrome, how many users are using Safari, those things, like internet browsers, what is the page viewed per minute in Safari, what is the page viewed in Chrome. We are going to take that data and we are going to write that data into after doing some aggregation function, we are going to write what is the total page view and what is the date. So we are going to write that inside our BigQuery. So these are the these are the column names like IP address, user ID, latitude, longitude, timestamp. Those things you will be given respective data type. And same way, it is going to be in JSON format. We are going to pass the JSON and we are going to decode using this UTF-8. So that is what this pass JSON does. And this get event timestamp class, what is this? No, it takes one method. It creates one method. That method is process. So it takes the timestamp. So here we'll have the timestamp data, right? Timestamp. So we'll take the timestamp. So if you see line number 21, we have on timestamp. We'll take the timestamp. We'll convert that into UTC time with this structure, and we are going to create, or we are going to write this inside a new column called event underscore timestamp. So this is what, this is a two transformation, P transformations, which we are going to do. And obviously the next thing is pass and get event timestamp. So here also we have one more function called expand. So we are going to parse it and we are going to get this. Basically, these are the two methods which we are going to call inside this pass and get event timestamp. So here we are actually reading the P collection. We are doing the pass underscore JSON and get event timestamp function also. So this is this and this are called here, and here you will be able to see this. So it is going to return this P collection one, and then we are going to write that P collection, which is in the form of JSON. It will have all the columns. So we are going to take two columns. Only one is page views, the next one is start time. So we are going to take that JSON, we are converting into dictionary object. That's it. So this is the transformation. So this is the actual data which we have. We are going to do some transformation, like we are going to pass the JSON and we are going to create a new column which has this timestamp to UTC, and we are going to write or return that into P collection. And from that P collection, we are not going to write all the columns. Instead, what we are going to do is we are going to write only two columns. One column name is page view. So what is the page view in Safari or in Chrome or in Mozilla or in Firefox, and what is the start time of that particular thing. We are going to write these two things to your in our final BigQuery table. So we are not going to write all the data. So here you can see these are the runtime arguments, like project, region, staging location, temp location, runner, input topic, and table name. Input topic is the PubSub topic name, and table name is, it is going to be the BigQuery table, like sync. So all those things, like we have already discussed about those things, and we are just setting the options here. And then this is our table schema, like page views and start time. And this is what the query is. We are going to do, or we are going to aggregate the query. This is an aggregation query, and it is going to do that interval in 1 minute. After 1 minute, it is going to insert the data inside this BigQuery. So select count star, like the page views and the start time. It is going to write into BigQuery. It is going to write into the BigQuery final table with interval of 1 minute. And this is the actual pipeline. So you are going to read data from PubSub and pass and get event timestamp. So this is what we will be able to pass and event timestamp. We are calling this P collection inside here. Pass an event timestamp with output times common log. So common log is nothing but our actual data type, whatever the data type which you are going to do. And SQL transform, this is where we are calling this SQL query. So this SQL query is going to do an aggregation function where it will get the total count of page views and the date time, start time alone, and rest all the other columns you are not going to write into BigQuery. And then finally we are going to convert that into dictionary, and finally we are writing it into BigQuery with table name, schema, table name, table schema. This is what the table schema is, and the table name, it is from the output, like it is from the parameter itself, and create if needed, write append. So we are going to write the table at the runtime. So it is going to create the table at the runtime. So this is one script, and we are going to, now we'll go, like I have explained you what is the ETL pipeline which we are going to build. Now we will go into this Jupyter lab. So our Jupyter lab is ready. You can just click on this open Jupyter lab, and if you wanted, you can just click on this and you can go inside all the parameters, default parameters, whatever we configure, whether it is present or not, you can just go through it. hardware, software security, all those things. And we are inside this Jupyter lab. So once the Jupyter lab is launched, you will be able to see a similar Jupyter notebook, which we like as a data engineer or a machine learning engineer or a data scientist, we will be using this Jupyter notebook. We'll just click on this Jupyter notebook and we will be able to work on this. But now we are not going to use Jupyter notebook because it is going to happen, like consider the scenarios happening at the real time or at the enterprise level. So what we will go is, everything will be in the form of terminal. We have to just click on this terminal and terminal is there. Now we are going to clone a GitHub repo. So you can just copy this. You can just copy this and go here and just click on this clone. And it will take some time to clone this repo. Here you can see training data analyst. This is the one which we are going to clone. This is from Google documentation itself. So you can just see, you can just go here, paste it here, and you'll be able to see it. So this is the repo. This is from Google Cloud Platform, and we are using this repo for our learning purpose as well. And it is cloning now. Once it is cloned, we'll just go into this path. So I'll give you this as well as this comments, everything in my GitHub. You can take it from there. So here you can see, just going to this training data analyst under quest, you will be able to see Dataflow Python. So inside this Dataflow Python, we are going to use this SQL streaming, and this is the lab which we are going to use as well. So I have made few code changes as well. So I'll just copy that and I'll paste it here. So whatever I explained you, I have just added that there. That's it. So the next thing is we are inside this SQL streaming analytics lab. So we are inside this one. So I'll just go into this SQL streaming analytics lab, and I'm going to save this part. Like if you just type pwd, you will be able to. I'm going to save this part inside a variable. So export base directory equal to this part. So if I do that, you will be able to see this. So now if I wanted to see this, you can just screen echo dollar base underscore dir, and you will be able to see this. I have just copied this file and stored inside this base underscore dir value. That's it. That is what I have did. And the next thing is, we are going to create a virtual environment. So now we are inside this base. Now we are going to create a virtual environment. In order to create a virtual environment, we are going to do this sudo apt-get update. So we are just updating all the packages, and then we are going to use this sudo apt-get install python 3 virtual environment. So just click on this, just install this as well, python 3 virtual environment. And next we are going to create a virtual environment name df-env. That is our virtual environment name. So if you can see, python 3-m v environment df-env, that is our virtual environment. Now we are switching to our newly created virtual environment. So here you can see we are inside our base directory. Now we'll just press it here and we will be into this df-env. So we are inside our virtual environment. So here we have to install all the packages, all the Python packages, and Apache Beam, those things and all. So we are just installing it. It is not mandatory you should create virtual environment. You can just click on whatever the base environment is. You can just skip the steps and you can just do it. You can just start from here itself installing the packages. If you want, you can create a virtual environment as well. So I've just created a virtual environment for learning purpose. You can just skip that step as well. It is not mandatory. So the first thing is, you have to make sure the API of that services. For example, like we are using Dataflow, we are using cloud storage, we are using cloud PubSub, and we are using BigQuery. Make sure before entering into this, you have to cross check whether the API of that particular services are enabled or not. If it is not enabled, you have to make sure that it is enabled. So the next thing is, we are going into our base directory. Once this is done, we are going into our base directory, and here we are going to execute a streaming shell script. So here you can see we are just into this quest and Dataflow Python, and you will be able to see this. So we are going to create the pipeline syncs. So what is the project ID? It is going to get the project ID from this, and it is going to create a project ID like cloud storage bucket. One is this gsutil cloud storage, and the other one is Golang cloud storage, and it is going to create a data set called logs. and it is going to create a cloud PubSub topic called my topic. It is going to create all those things. So you can just click on this and you can copy this source, and you can just keep this like source and create streaming dots underscore syncs dot. It is going to create all those things for us. So if you want, you can cross check that as well. So you can see cloud storage bucket has been created, data set is also has been created, and topics also created. My topic is what the cloud PubSub topic is. Now we are again switching back to base directory. So now we are inside this analytics lab, and this is where we are going to export the regions, like what is the project ID we are going to use, or this is what the parameter is. So we are going to export this, like export region, export bucket, and we are going to export the pipeline, those things, all those things I'm going to export it. Export in the sense it is going to get into that real time, like I explained you the code, right? It is going to set that value to this particular variables. So runner is going to be Dataflow runner, and the topic is also going to be whatever the topic, my topic, which we created, right? It is going to be that. Export PubSub topic is also going to be this, and BigQuery sync is also logs, and minute traffic is the table name which is going to create. So log is one, the data set which is which it created. Now we are going to create a table that is minute underscore traffic. Now we are going to execute this, like just you can just Python 3, what is the streaming minute traffic equal pipeline.py, project ID, region, staging location, everything it is taking as an argument which we are passing it from here. So you can just click on this and you will be able to see this as well. So it will take 2 to 3 minutes to reflect inside our data flow. You will be able to see this is a streaming pipeline, so it is going to be continuously running. Our cloud PubSub topic, it is going to be continuously running. Data flow job, it is going to be continuously running. BigQuery, obviously it is a data warehouse solution, and serverless service. So whatever the service which we are using in this particular demo, everything it tends to be an serverless service. Like PubSub, it is again a serverless service, and a big data service which is mainly used for a streaming pipeline. Cloud Dataflow, serverless service which works on top of Apache Beam, and no compute, nothing we don't need to do, everything will be happening at the runtime itself. The third one is cloud storage. Obviously we are going to stage logs, temporary logs, staging logs, all those things will be there, and it is also a serverless based service only, and it can scale up to exabyte. And obviously the sync is also, it is going to be BigQuery data warehouse solution, and obviously serverless. So whatever the service which we are using, everything it is going to be serverless only. So I have opened one more terminal. So this is where we will be installing, we will be calling the main script file, all those. So here I'll just open this. I'll go into my data flow. I just wanted to go into this data flow, and we will be able to see it's not been 1 or 2 minutes. Here you can see one streaming pipeline has got, it is currently in the running state. So here you can see read from PubSub, pass and get the timestamp, count per minute, convert to dictionary, and write aggregation to the BigQuery. Whatever we have wrote, everything is present here, and this is what that once the data is coming, you will be able to see it here. Now we are going inside how to enable that data flow, or how to enable the traffic. We are going to initiate that script. So I'm just copying this one, like going inside the data flow Python. So here, I'm already inside this data flow Python. I can just ls, and you will be able to see this here. And we are going to run this bash generate streaming events.sh. So I'll just click on this and I'll explain you what is that. Generate streaming events.sh. So where it is generate. So if you see here, it is installing the packages from this. It is calling this shell script sh.install. Like it is going to run this shell script sh install packages, or whatever the packages here, it is going to install it, and then it is going to call this user generator.py. So what is this user generator? So based on this user generator only, we are going to create or generate the data, like CSV file itself, it is generated then with the help of this faker package. So here you can see faker.firefox, faker.chrome, Safari, Internet Explorer, Opera, all those things, latitude, longitude, input user agent, like generate user and write to CSV file. So this script file, it is going to generate the fake, here you can see users.csv. This is where you will be able to see this script file it is generating here, like ID, IP, lat, longitude, opt into marketing, those things and all, user agent. And then once this is done, then where it is going, like echo generating synthetic events. So it is going into the streaming events generator.py. It is going to inside this. So streaming events generator.py. So it is where arguments like pubsub, date time, dictum coda process. So it is taking all the arguments. Here you can see. Yeah. So it is taking this argument, it is like extracting resource like IP, user ID, latitude. So whatever we have there, right, inside our main script file, you will be able to see that here. So I'll go here. So here, IP, user ID, latitude, ing, timestamp, HTTP request, HTTP reference, number bench, all those things. This is what the log fields are. From this file, we'll be getting the actual data, and this data will be pushed into Cloud PubSub, and from Cloud PubSub, we'll be like our Dataflow script file. Like Dataflow script file will come into the picture, and according to our transformations or according whatever the SQL query which we have, everything will be done there. So this is how we'll be using this. You can just clone this and you can just go through this code as well, but this is what the main thing is. Here you can see current virtual CPUs to total virtual CPUs time, those things, all those things you'll be able to see, and then pipeline options as well, you'll be able to see it here. Just click on this Google Cloud, open BigQuery. Due to this time constraint, I'm not explaining, like I'm not getting too deep inside that, explaining you the streaming event shell script file on dot. So here you can see that log file is there, and if you expand, you will be able to see this minute traffic. So you can just previews, you will be able to see the data. If it is not, you can just open the query and just press R, and you will be able to execute this data. So after a minute, so totally there are 3 records. So after a minute, with the interval of 1 minute, you will be able to see one more record also generated here. So totally we have 116 page views, start time. So totally 2 page views, and what is the start time. So here you can see 14, like 14, 15 and 16, those things you will be able to see in 1 minute. You will be able to see the record is generated. So the same way, it has not been 1 minute here. So we'll just wait for 1 more minute, and we'll be able to see one more record added to this Cloud BigQuery. So this is going to be a streaming pipeline. So whatever the data which we are processing, we will be charged only for that particular thing. For Google, let it be Cloud PubSub, let it be Dataflow, let it be BigQuery, or let it be cloud storage as well. We are going to charge only for the data store, and if you wanted to hard stop it, you have to just stop it here. So I'll go here. You will be able to see one more record also. No, it is not. So you have to just wait for 1 more minute, and you will be, here you can see 14, 15, 16, and after 1 minute, you will be able to see one more record also, like 117 page views. And if you wanted to stop, obviously you have to stop this pipeline just by clicking cancel it and stop the job, and just close this, go to this notebook and stop or delete your notebook as well. So I hope you have learned how to build a streaming pipeline. In other videos, I'll explain you more scenarios, like I'll explain you more scenarios including streaming as well, like with different scenarios with using data prop, those things and all. If you have any questions or doubts, please post that in the comment section. I'll give you all the descriptions, whatever the comment I have, everything I'll have it. I'll move it to my GitHub, and I'll give you the link also. You can take a look at it, and if you have any questions, any doubts, please post that in the comment section. I'll take a look at it and reply to it as soon as possible. I believe you learned something from this video. Please do like, comment, share, and subscribe to Cloud and AI Analytics, and please press the bell icon as well. And I'll see you in the next video with more interesting materials, with more interesting learning materials, contents from Google Cloud Platform. Until then, it's bye from Vignesh. Happy learning, and don't forget to subscribe and support to Cloud and AI Analytics, doing it the cloud way. Thank you.